we should be aware of type 1 and type 2 errors. Type 1 error is when we reject the true null hypothesis. When it's correct, we reject it. That's a type 1 error. And the type 2 error is to not reject or fail to reject a false null hypothesis. But you'll pick this up in your reading. With question 1, which has several parts. First part wants us to formulate alternative and null hypotheses. Well, because the suspected condition is that the number of days in receivables has increased from the historical average of 45 days. It suggests a greater than alternative hypothesis will be that mu, the population mean, is greater than 45 days. And we have them here for you to peruse. The second problem wants to know which would be the alternative, the most appropriate test statistic. Well, we have a population with an unknown variance, and that makes it best to use the t statistic, where we get into degrees of freedom, n minus 1, where n is 50, and therefore n minus 1 gives us 49 degrees of freedom. Because the sample size is large, the z-test might be acceptable, because we could rely on the central limit theorem. But in general, the t-test is most appropriate when the population variance is unknown. The third problem, you will see the working out here using the t-statistic. This equation would have been the same if we had used the z-statistic. But because we're using t, degrees of freedom, minus the already determined null hypothesis of 45 days or less, sigma, which in this case would be the sample standard deviation, and square root of n, where n is the size of the sample. Simple arithmetic gives us t equals 3.536. Now, t of this size allows us to conclude that it is much larger than both. Well, this is problem 4, but as we would have seen in problem 3, with levels of significance being 1.677 for the degrees of freedom, 49, because n minus 1, n would be 50 minus 1 would give you 49 degrees of freedom for the 0.05 level of significance, and that gives us a number here. You'd see it in the table, 1.677. For the 0.01 level of significance, we do the same thing. Start at 49 degrees of freedom, go across to the 0.01 level of significance, and we'll see 2.405. What we would have found then is what we refer to as the critical value, and we would reject the null if t, which we are going to work out here, is greater than 1.677 for the 0.05 level of significance, and if t is greater than 2.405 for the 0.01 level of significance. We set up the equation, which you're already familiar with, and we have found that t is 3.536. Now, because this 3.536 is bigger than both rejection points for 0.05 level of significance and 0.01 level of significance, we can confidently conclude that customer payments have in fact slowed down, which means that mu is in fact greater than 45 days. So we reject the null, because this was exactly what the alternative hypothesis was contending, that mu was greater than 45 days. And we have confidently established it here. Our second question asked us some pretty similar things. You'd be familiar with the question, of course, before we even start to do the working. The hoped for or suspected condition in this particular case is that the population mean net income exceeds 24 million. So our null hypothesis, mu, would be that the mean is less than or 24 million, and the alternative hypothesis would be contending that mu, the population mean net income, is actually greater than. So we need to establish that. Again, we use a t statistic, but why would we do that? The sample size is very small, 6, giving us 5 degrees of freedom, and the variance is unknown. So we have little option but to use a t statistic in this case. So that would answer question 2. The third part of the question wants us to identify the rejection points. We just had some practice doing that in the first question, so let's do that again here. Level of significance 0.05. Using the t distribution, degrees of freedom would be 5, which is n minus 1, 6 minus 1 equal 5. And we would be intersecting again with the alpha equals 0.05 line, and we find the rejection point or critical value to be equal to 2.015. And we'll have to reject the null if t turns out to be greater than this 2.015. So we calculate t, plugging in the values, which you will be able to do quite easily. We find that t is equal to 1.4697. Therefore, we cannot reject the null because t, the critical point, does not exceed 2.015, which is what it would need to do to convince us to reject the null. And so we conclude that the difference between the sample mean, because the sample we took suggested that mu was 30 million, and the hypothesized mean, because our records historically had showed us that the average would be around 24 million. So under the difference between them now shows that it is not statistically significant. So we don't have a basis for rejecting the null. So the management contention that new approaches and what have you have created a new paradigm where we can expect 30 million rather than $24 million net incomes really has little statistical backing. Thank you.